Friends, I am Sanjay Mishra, your maths teacher. So, we have discussed in part 1 of our video from chapter 7 coordinate geometry. We have discussed 2 or 3 topics. First was the distance formula, by which we can find the distance of 2 given points or 2 places in a Cartesian plane. Okay? And second one was the section formula, by which we can find the point of coordinates of a point of a line segment which divides the given line segment in a ratio. Okay. Now we are going to discuss some more important facts from this chapter. Okay. So now, how will you trace a point in the Cartesian plane or represent a point whose coordinates are given in the Cartesian plane? Suppose a point having the coordinates x and y. It has the numeric value, both represents the value of x as well as the value of y. First, the value of x is known as the abscissa and the value of y is known as ordinate. This is also known as ordered pair. Got it? Now, as we know that this is the Cartesian plane, horizontal axis is known as x-axis, vertical axis is known as y-axis. This is represented by x-axis dash and y dash. These two axes are intersected mutually at right angle. Okay? Where they intersect to each other, that point is known as origin, and its coordinate are 0, 0, means abscissa and ordinate both are 0, 0. Is that clear? Now, these are 4 quadrants. First quadrant, second quadrant, third quadrant and fourth quadrant. First quadrant, in this quadrant, abscissa and ordinate both are positive, as we can see here, x1 and y1. In the second quadrant, abscissa is negative and ordinate is positive. Okay? Abscissa means x is negative and ordinate y2 is positive. Got it? Now, in the third quadrant, abscissa and ordinate both are negative. Both are negative. In the fourth quadrant, abscissa is positive but ordinate means value of y is negative. Got it? So, this is called the sign convention for the coordinate geometry in a Cartesian plane, by which we can represent any point in the Cartesian plane. So, we can easily identify the position of the point in a Cartesian plane by seeing the sign of the point. Suppose the point is -2, 3, where -2 is the value of abscissa and 3 is the value of ordinate. So we can say that this point will lie in the second quadrant, where abscissa is negative -2 and ordinate is 3 positive plus 3. Okay, so it will lie in the second quadrant. Hence we can draw other points in the Cartesian plane according to their sign convention, what they have. Got it? Now, next point is area of a triangle. Suppose ABC is a triangle having the coordinates for A x1 y1, for B x2 y2 and for C x3 y3. We can find the area of this triangle with the help of this formula. Area of triangle is equal to half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. We can put these values from the given points. Got it? Suppose if the area of triangle comes 0, it means given 3 points are collinear. Collinear means given 3 points are lying on the same straight line. So, what are the collinear points? When 3 or more than 3 points lie on the same straight line, all points are known as collinear points. And this is the condition for collinearity of 3 points. If area of triangle comes 0, it means 3 given points are collinear. They are not forming any triangle. Got it? Now, our next point is area of quadrilateral. Suppose we want to find the area of a quadrilateral. Suppose there is a quadrilateral ABCD having the coordinates A, B, C, D like this: x1, y1, x2, y2, x3, y3 and x4, y4. In this condition, we can use the same formula for first 3 point ABC and we can find the area of triangle first. Similarly, we can find the area of triangle second. And when we add them, we get the area of the required quadrilateral ABCD with the help of this formula. So we have to apply this formula 2 times. Got it? Now, our next point is coordinates of the centroid of the triangle. What is the centroid? Centroid of a triangle, a point inside a triangle where all 3 medians of a triangle are concurrent. Concurrent in the sense where they meet, where they intersect to each other. Got it? So, where PA and QB and RC are 3 medians of the triangle and they are intersecting to each other or they are concurrent to each other at a point G. So G is the centroid in this condition of this triangle PQR. Now, coordinates of the vertices of this triangle PQR are given, where the coordinate of P x1, y1, Q x2, y2, R is x3, y3. We can find the coordinates of the centroid also with the help of this formula. X is equal to x1 plus x2 plus x3 upon 3 and the value of y comes from y1 plus y2 plus y3 upon 3. Okay? So thus we can find the coordinates of the centroid of a triangle PQR with the help of this formula. And this is the definition of centroid. These are 3 medians. 2 lines are intersect to each other. Then we can use the word intersect. What? When 3 or more than 3 lines are intersecting to each other in a common point, then this point is known as the point of concurrency, or the lines are known as concurrent lines. So here 3 medians are the 3 concurrent lines. Got it? Now, this was the explanation part of this chapter, coordinate geometry. So you can go through this video and you can try the exercise 7.3. This is given in NCERT textbook, and with the help of this content you can also try the problem in the other concerning books as well as R.D. Sharma, R.S. Agrawal, Monica Kapoor, Nagin, etc. Okay? So there is no problem. If you are having any doubts, then you can ask to me and feel free for asking your doubt. Have a good day.